As Matt said, we have limited resources. तो हमने एक जागरूक टाइप का कुछ करने की कोशिश की है बच्चों के लिए, जिसको हम साइंस से रिलेट करेंगे लेटर ऑन। तो हमने क्या किया है कि पेपर में कुछ लिखा है और वो बेसिकली बच्चों के लिए इनविजिबल रहेगा। दे डोंट रिकॉग्नाइज कि हमने लिखा क्या है, बट वी हैव रिटन एंड वी हैव एडेड टर्मरिक सॉल्यूशन। तो उस टर्मरिक सॉल्यूशन से अब हम वो चेक करेंगे कि व्हाट एक्चुअली इट हैज रिटन ऑन द पेपर, जो हमने लिखा हुआ है। तो उससे हम बच्चों को एक तो उनकी क्यूरियोसिटी जागेगी कि हमने कुछ लिखा नहीं था। दैट मीन्स उनके लिए वो ब्लैंक पेपर है, बट एज सुन एज हम उसमें जैसे ही टर्मरिक यूज करेंगे तो वो अब पता लग जाएगा कि व्हाट वी हैव रिटन। तो वी कैन से इट इज अ टाइप ऑफ इनविजिबल इंक। तो वो हम बच्चों को जब इस तरह से टर्मरिक जब धीरे धीरे उसमें बेसिकली वो स्प्रे किया जाता है, बट वी हैव स्ट्रॉ, तो हम उसको लिखा के देख रहे हैं व्हाट वी हैव रिटन एक्चुअली। तो एक तरह का इनविजिबल इंक और एक तरह का जादू भी बन गया है हमारे लिए। एंड दिस इज द फर्स्ट एक्सपेरिमेंट। सेकंड एक्सपेरिमेंट, एज टर्मरिक इज अ मतलब इट डजंट मिक्स कंप्लीटली विद द वाटर, तो इट इज फॉर्मिंग अ हेटेरोजेनस मिक्सचर। तो यहाँ से हम बच्चों को क्लासिफाई भी करा सकते हैं कि वी हैव सॉल्यूशन, टू टाइप ऑफ सॉल्यूशन, एक होमोजेनस होगा, एक हेटेरोजेनस होगा। तो जैसे आप देख रहे हैं कि इसको क्लियर दिख रहा है, तो बेसिकली एनीवेज है, बट हम इसको वाटर कंसिडर कर रहे हैं। तो ये क्लियर सॉल्यूशन है, तो हम बोलेंगे इट इज अ होमोजेनस इन नेचर, इट डजंट हैव क्लियर बाउंड्रीज। और बट अगर हम वो टर्मरिक का सॉल्यूशन देखेंगे तो वो हेटेरोजेनस है, पार्टिकल्स कैन बी विजुअलाइज इजीली। और फिर उसके बाद उसी को ही हमने एक्टिविटी से जोड़ दिया है कि जिसमें हम एक फ्लैश टॉर्च लाइट जब फ्लैश करेंगे उसमें, तो उसका पाथ जो होगा वो विजिबल होगा। उसको हमने फिर इसको सिंगल इफेक्ट से कनेक्ट कर दिया।
So actually you can see small particles moving here and there over in this. So it easily shows that it is not completely missing small particles, and this particular phenomena is called Tyndall effect in the science. So actually particles, heterogeneous solutions, yes. So one of them is called colloidal, another one is called suspension. So as far as I'm concerned with this one, the solute particles are very big. So they are not actually miscible with the solvent. They're not getting fitted between the molecules of the solvent. So you can see them that they are moving here and there in the solution. You can see by putting light on it, you can actually see the movement. Similarly, colloidals are the same, but they are a little bit smaller. That we can do if you want to put our lemon into the water. You will be able to see that mudiness. The particles are little small, but even then they are not completely soluble in. But if you're going to see NaOH and you're going to put light on the NaOH solution in water, you will see it's crystal clear. You cannot see it. So this kind of solution is called homogeneous solution. So you have to understand one thing: we have taken a solute and a solvent. So you can understand it in a way that they have not combined together. Concept is they have not combined together. The only difference is whether the solute particle is able to fit between the solvent particles or not. If it is able to fit between the solvent particles, it will form a crystal clear solution that will be called a homogeneous solution. When you will put light on it, you will not see anything, any movement. But if you are going to take a heterogeneous solution where the solute particle is a little big and is not able to fit in between the solvent molecules, so when you put light on it, you will be actually able to see those particles. This is very important.
And see the color.
And this is like the first experiment that we carried out. Actually, it's for invisible ink. So you might be able to understand. See, there are two types of chemicals in the nature. Everything is surrounded. We are surrounded with chemicals, but we need something to categorize them. So we have a very broad classification, which is called acid and base. Now, acid has certain set of properties and base has also certain set of properties. The first thing that we should be able to do is to distinguish whether it's an acid or it's a base. Once you are able to do it, you will be able to classify you will be able to predict their properties. They're on certain set. So how do we identify an acid and base? The simplest thing is we have a very good natural indicator at our home, which is called turmeric. So what we have actually done over here, we put up a basic solution, wrote something on the piece of paper, let it dry, and then we take this turmeric solution and we put it over the written thing. So since turmeric, an indicator is a thing that can actually tell whether it's an acidic or a basic nature thing. So when we put turmeric on it, the base comes in contact and it immediately changes its color into red. But the same thing if you are going to carry out with a base, the turmeric is not going to change its color in the base. So this is how we'll be able to classify. The main thing you should know by this activity is why we are doing it. Because we are surrounded by a lot of chemicals. It's very difficult to study them. We need to categorize them. If you are able to categorize them into acid and base, you can easily predict some of their properties. Or even if you're not, even if they show some exception in the properties, you'll have a valid logical explanation for it. Thank you.